According to your textbook, a variable is a letter that stands for or represents a mathematical quantity. All that really means is that if we want to generalize what happens when we add 5 to something, but we're not sure what we might be adding it to, we can let the something be represented by a letter. We often use X, but sometimes you'll see T or Y or A or B or P or Q. Really, any letter will work. What we're saying when we say let X represent a number is instead of X, say a blank space. Then what if X is 3? Well, if X is 3, then the answer to this particular problem is 8. But if X is 7, then the answer is 12. What's happening here is that as I choose different values for X, the value varies. So we call X a variable because it's standing in for the value here, which is varying according to the problem. We can talk about two numbers being equal, so we can talk about two variables being equal. We can talk about two numbers being not equal. Like here, 3 would only be equal to 3. Since 3 is not equal to 5, we use this symbol. If X is equal to Y and X is, say, 7, then that means that Y must also equal 7. If X is not equal to Y and X is 7, then Y could be any other number except 7. We don't know what that is. Since we can add two numbers together, we can add two variables together. We can subtract two numbers, so we can subtract two variables. Variables are just numbers. It's just that we don't know what numbers they are. We can multiply two numbers, so we can multiply two variables. And we can divide two numbers, so we can divide two variables. Variables are just numbers. We just don't know which numbers they are. Later in the quarter, we'll be learning how to figure out what number a particular variable stands for. But for now, it's sufficient to talk about variables as just being a placeholder for a number we don't know yet. Here's another comparison. 3 is less than 5, so we use this symbol. We can also say that X is less than Y. If this weren't 3, but say 8, then we could say that 8 was greater than 5. If X is bigger than Y, we can say that X is greater than Y. And in fact, we can say 8 is greater than or equal to 5. So we can say that X is greater than or equal to Y. A note about multiplication. A minute ago, I used this symbol to indicate multiplication. That's fine, but I can also write 3 times 5 as 3 dot 5. The dot also means multiplication. Similarly with X times Y, I could have written X dot Y. With variables, we even get away with this. X, Y, with no symbol in between them at all, means X times Y. Now I can't get away with that with numbers because 3, 5, with no symbol between them means 35, not 3 times 5. So this does not suffice for multiplication with numbers, but it does with variables. One last one. 3 times 5 can also be written with one or both of the numbers in parentheses, like this. That means 3 times 5. This also means 3 times 5, and so does this. And I can do that with the variables as well. If I want to, I can write X times Y as X times Y, or x times y, or like this. And now a comment about division. 3 divided by 5 can be written like this, 3 divided by 5, or we can write 3 over 5. The fraction 3/5 means the same thing as 3 divided by 5. Likewise, with variables, x over y means x divided by y. I can also write 3 divided by 5, or x divided by y. Notice when I write 3 divided by 5 this way, the 3 comes first. I'm taking 3 and dividing it up into 5 parts. That's going to give me a smaller number than 1. 3 divided by 5, 3/5 is less than 1. When I write a long division problem, though, the 3 goes on the inside. 3 divided by 5 is 3 divided up by 5, or 5 goes into 3. Okay, just one last thing for this video. It's not inherent in the title of this section, but I want to talk a little bit about what it means to be an algebraic expression. An algebraic expression is a combination of numbers, variables, operation symbols, and sometimes grouping symbols. So here's an example. This is an algebraic expression. Here's another one. Here's another one. They're getting more complicated, aren't they? But notice that they're just a combination of numbers and variables, operating symbols, and I haven't done one yet with grouping symbols. Let's just do one of those now. Here's another algebraic expression. Let's see if I can make it really messy. Grouping symbols are parentheses, but they may come in different forms. So for example, 2 times all of the following, 3 minus 6 times x minus 1. The different kinds of grouping symbols I've used here are really just a way to keep things straight visually. I could just as easily have written this way. But I think it's harder to tell with the second version which parentheses here go with which parentheses on the outside. Because I used a different shaped parentheses in this version, I think it's easier to tell that this square bracket here closes this one here, and this parenthesis closes this parenthesis here. There's one more type of grouping symbol. If it gets really complicated, if we have a whole lot of things going on inside grouping symbols, then sometimes we use a curly bracket or a curly brace in addition to the parentheses and square brackets. So here's what I mean by that. Okay, that's pretty messy. But notice that the parentheses clearly go with each other. These parentheses go together. And these square brackets clearly go together. And the curly braces also. Whenever you're working with these kinds of grouping symbols, remember from pre-algebra that we always want to do what's inside the innermost parentheses first, if possible. In this case, we can't do anything inside here, but if we had a number instead of a variable, we could do this subtraction problem. Then we would do whatever's inside the next nested set of grouping symbols. So we would put together whatever was inside this group next. And then we would work with what was in there and combine it with what's inside the largest grouping symbols, the curly brackets. Last, we would combine whatever we had in here with the 6x minus. Okay, that's pretty much it for variables. I'll see you in the next video.